I want to start it by doing this. How many of you have ever been through a lesson on probability as a student? I bet everybody in this room has. One time or the other, you've had a probability lesson. And I taught math for 27 years in a public, well, I taught math for 16 years, and I went into administration. And most math classrooms, if you aren't careful, fall into this type of a deal. Let's see if you can help me remember. What usually happens first in most math classes?
Warm up on the board.
Okay, say that again.
Warm up on the board.
Okay, there's some type of a warm up on the board, and then what did you say, Lori?
They call roll.
Okay, well, we call roll, and I can remember what my teachers used to do. They would say, does anyone have any questions over last night's homework? And then the teacher would probably do something really, really engaging, like say, here's the typical engagement. Okay, today we're going to talk about logarithms. Open your book to page 264. Now, doesn't that make you really want to spend the next 54 minutes of your life in math class? All right, let's break this lesson down. There are 5 E's. What's the first E? Okay? Now, I was as engaging as I could be at 8 o'clock in the morning. What did I do to engage you a bit? Say it again. Gave you some dice, and Amar immediately jumped on me, and asked, did I have these out when you first got here? And my answer was, now, I could have had those sitting right there, and probably what would you all have been doing with them? A crap game would have been in session as class started. So I was pretty careful to control when I gave you the dice, but I want you to think about a probability lesson you may have had back in high school that involved a problem like, what is the probability that if you roll a pair of dice, you get a 9? And the one thing you probably didn't do in class was what? Roll any dice. You just worked that on paper. So I engaged you by giving you some experience with some dice. I asked you some questions. I asked you to make a what? Make a hypothesis, make a prediction. Okay? So for instance, if you want to think of some other mathematical topics, we think hypothesis is only chemistry and physics and biology. It's only science. In math, it's kind of like, what do you think will happen if we put a +1 after this equation? What do you think will happen to the graph? What do you think will happen to the graph if we put a minus sign out front? Make a prediction. Now put it into your graphing calculator and check your prediction. So being able to make a prediction is a good part of that engagement process. Now, what else I was doing was I was finding out what you knew and what you didn't know. Okay? There were some things that shocked me, to be real honest. I felt like somebody would have given me a different answer there at first. I wasn't expecting people to say some of the things that you did, and that's okay. But that let me know up front, I see what I've got cut out for me today. All right. What happened after that first E? The first E was engaged. The second E is explore. Okay? So what did you do explore-wise?
The trials with the dice.
Okay, the trials with the dice, trying to see how your hypothesis how it actually worked. You actually got a clear visual by having to make those marks in the column. You knew what made win and you knew what made lose, so it was easier to transfer later on. Now, I'm going to tell you the best definition that I can give you of exploration is this. Exploration is when you give the students a little while to try to figure it out on their own before you tell them how to do it. And that's totally counterintuitive to the way that most math teachers, and I'm one of them, so I can talk about me, work. Because what we do is we say, here's what you do. Step 1, step 2, step 3, step 4, now you go work 50 problems like it. Let the students work for a few minutes. See what they can figure out. Then you go to the next E, which is explanation, and you fill in the blanks. What they haven't figured out, you help to explain. And to the degree possible, I won't explain, but maybe I'll let some of you explain. And then what follows in that fourth E? Elaboration. Now, from your reading, what did you gather elaboration is all about?
Taking a similar concept and trying to make it applicable in an approved situation.
Okay, so in this lesson, everything we had done really up through the explanation was all about God. So elaborating is putting something in a different context. Okay. And then that fifth E was evaluation. And I was doing something more formal here at the end that would let me know as I go home that evening, ooh, I see I still got a little ways to go. But I was evaluating every time I stopped by your table. Now, I'm not going to pretend that I wasn't in fantasy land today, because today I had 5 stops to make at 5 highly engaged tables. Not, say, 15 stops with different levels of, right, Katie?
Yes, sir.
Exactly right. But it's a management issue.
Yep.
More than anything else. So, that's a quick trek through those E's, and we'll talk a little bit more about that in a minute, but I want to hit a couple of other things just because I would be guilty of malpractice if I didn't. I want you to think a little bit about a couple of the other things that we did. I asked you to tell me what percentage or how many rolls of the dice it took in order to get to that 90% level. And we put this thing into our calculator, and then we use that table to find the answer. Now, in this room, raise your hand if you're degrees in math. 1, 2, 3, 4, 5. 5 math people? Okay. Now, I essentially ask you to tell me when is 1 minus 5, 6 to the x at least 90%. The floor is now open for nominations for how you solve that without a calculator. Okay, tell me what to do first.
First, you need to isolate the x, so you want to subtract your 1 and then
Okay.
multiply by
Okay, I'm
9.
impressed already that she used such a fancy word. I'm doing great. All right.
Now we'll multiply each side by -1.
What I write down?
So you have 5, 6 raised to your x. And now you're going to flip your sign because you're multiplying by a negative. And then you got your number as a positive. And now you're going to rewrite it in that logarithm form to approach it better. So you're going to have your log of your base at the bottom, or in the x out in front, right?
I'll do
Am I
whatever you
doing
want.
it right?
Do whatever you want. You tell me what to write down. I was
Would
getting.
it be x, the word log, 5, 6 is your base? What is that? Because you have your, do you mind if I write it down? So you have your point, your 5, 6 to the x, your a to the x equals your log x to the, so actually it's log x 5, 6. Is your x your, I'm embarrassing myself.
Well, that's okay. That's okay, because, go ahead.
No, she's actually very close,
Yeah.
because that would have a default base 10, so that's just log 5, 6 less than equal
So
0.10.
it's
Mhm.
natural
And
log,
then you
yeah.
divide by
See,
log 5,
The
6.
the good thing is that you all are all making my point. When you all went to high school, who took Algebra 2? I'm saying in general, who took Algebra 2? What type of student? College-bound students? Perhaps more advanced students? Who takes Algebra 2 now?
Should be everyone.
Everybody. Well, we don't have the answer yet. We're still debating on what it is, but with that calculator, with putting that into the calculator, that answer was accessible to how many people? Pretty much everybody. But it's because you did this, and the reason I wanted to bring that up is one of the big standards now is modeling. So if students learn how to take a situation and model it using algebra, technology can help them arrive at the answer. So that's a really important thing. The other thing that I want to tell you, I went up and observed all of our interns last year. And Katie, you can be of help on this. Every class that I went to, I saw an exit slip.
Yes, sir.
Fail none. And every class that I went to, the best I recall, I saw some type of bell ringer.
Mm-hmm.
Okay? Y'all ever remember bell ringers back in school? I don't know what a bell ringer is.
We had something on the board when the bell rang to switch classes. So as soon as they came in, they had something on the board to come in. They had a routine. They got their folder, and they started their bell ringer so that I could go ahead and get started on everything else that I needed to while they were working on their warm-up.
So it served it was multi-purpose.
Mm-hmm.
Go through those purposes again.
It allowed me to, one, stand at the door so that I could greet people at the door, and they would already have something that they knew they were supposed to come in and do when they got into the classroom. And then once the bell rang and we were all in the classroom, it allowed me to focus on circulating to take attendance, so that I didn't necessarily have to take explicit time to call roll because they were already hands-on working on something. And I could use it in two ways. I could use it to review something that I thought, hey, maybe we didn't quite get what we should have out of yesterday's lesson, or to kind of tweak them and preview the skills that we were going to need to do for the lesson that day.
So it does serve that dual purpose. If students don't have anything to do when they come in the room, they'll decide what they want to do. Well, it's a routine. Here's what you start. Now the one thing that I like that she said is, I like to use bell ringers to help me out for what's about to happen. So if I had been doing a bell ringer for you today, I probably would have had questions like this. If I roll a die, what's the probability that I get a 6?